Okay, so you got to know the video here. I'm going to be making a campfire for as a commission for a client. I'm going to show the process of going through making it, and hopefully you guys can learn a little bit of something here. Um, Instead of using the Voltage tile system, we're going to once again just use the basic Minecraft tile entity system. It's a little quicker considering that a lot of these do not need a lot of interaction. Plus, for you guys who are not using Voltage, you'll learn more. We're going ahead and I've created the block class. I've extended block container. Block container by default is going to handle our breaking of the tile, and that's about it. The rest of the stuff in here is not really important. Um, we are going to actually need to override this really quick, so let me go ahead and copy this. When our tile breaks, we need to drop the inventory because we're going to be making a we're going to be making a furnace is what we're going to be doing right now. In visuals, it's going to look like a campfire. In functionality, it's going to be no different than the furnace in Minecraft. It is going to have its own recipe list, which will make a recipe handler here. And if I didn't actually hit cap lock when I did that, rename this. So I'm going to go through and I'm going to rename these real quick. How this works is pretty much world X, Y, Z, block, and then metadata. They pass in the block as well on this one, so you could recycle this class and use it for whatever you want it to use it for. I've seen some mod developers go to pretty far extremes on how they want to handle this. For our case, we don't really care what's going on. We just want to empty the inventory. So we go to do empty inventory. And we actually want to do this before we call super break block, because once super block is called, we no longer have a tile entity. When you don't have a tile entity, you don't have an inventory. So in this case, we're going to go tile entity tile equals world.get tile entity x, y, and z. And then we need to make a campfire tile. So new Java class here, tile entity campfire. Now I'm calling this tile entity. If I was working with Voltage, this would be called tile, but only it would be called tile if we're using the tile class. If we're using tile entity, it's going to be called tile entity. It's good and important to keep with naming convention because when somebody's reading through your code, they understand what's going on. If you prefix it with tile entity, they know it's a tile entity. You prefix it with a block, they know it's a block. Prefix it with item, they know it's an item. If you start using your own convention, it starts to confuse people a little bit more, so it's a good idea to make sure when you're picking conventions to name your stuff, you think about the fact that not only do you have to read it, but somebody else has to read it. It's a good idea to always think about what somebody else is going to read before you do, because you may come back like 3 months after working and completely forget your own naming conventions. And those people that say they are not going to do that, I found almost every single person who has left and stopped working on their code and come back does not remember anything, pretty much. But anyways, we're going to grab the update method, and we want to grab the read and write method as well. I'm going to go ahead and copy the whole method and then gut them real quick. Because we do not want to override this code that's here. That's Forge's job to handle, or rather Minecraft's job to handle. We do want to put add override above them so we know that we are overriding something. Add override is actually optional. You're not required to use this, and if you're writing in an older version of Java, I believe Java 5 adds this. Anything before that does not have override. But you want to put this in here because lets you keep track of if you are overwriting something, and say you go to update or sometime in the future, this goes from read MBT to say save MBT, then it'll go like, hey, you're no longer overriding a method, and you can then go and change everything. But then we're going to call super read. Make sure you actually put the super in front of it. If you don't put the super, you're going to be calling this method instead, and you'll infinite loop back and forth. Super will take us to the method of the super class. That will make sure that code runs. If you don't run the super code, your tile will not save. Because in the super code, we save the tile we are. So we save the class name so we can reload it from the save file. We then save our location here. ID is the ID thing. Make sure you never overload these, and if you go to do something like, say you make your block pushable by a piston, if you move your tile and you don't make a new one, make sure you delete these out of your MBT data or you're going to fuck up. We've got that, and now we need our update method. So public void update entity, and you don't need to call super on this because there's nothing in the super method. This is our base level code. Then we go up to here, and we want to go if tile is instance of. We're gonna do tile entity campfire for this. Technically, what you would actually do is extend your inventory here. And actually, do I have an inventory class? Kind of want to save myself some time here. Yes, I do. So this contains inventory code. I do not want to rewrite this because it's always the same and it's just a pain to have to copy and paste into a class, and it makes your class length go up. So if you want to see this stuff, this is in VoltsEngine. You guys could go up to the repository and you can look through this. This should be the same as all of my classes here. And I actually do, wow, this is not really well implemented. I'm going to rewrite this here in a second because I don't want to use this style of handling. This is literally the old school style of handling, and what I want to do is go find my inventory prefab that I actually use and copy it in here. There's one I use for the tile class system that does function better. This is literally what it looks like, a direct copy and paste of the chest class. And saying by the fact there's nothing up here on the top, this class is probably ancient, which means this stuff does work, but I don't want to use an array here, even though the array is saved. All this class would work, although I don't want to initialize with an array there. So we're going to go and, if I can find what I'm looking for, okay, core VoltsEngine, content, prefab, tile. Actually, we don't want that one. We want it over here. So this is what we want to use as external inventory, but I need to find the wrapper that uses my external inventory. So we got the tile machine class, which then extends tile ints. That's not what I'm looking for. Tile modular machine, which extends modular machine base. Base then has simplistic code in it. This most likely has the inventory code in it. It does have the inventory code in it, so that's what I'm looking for. We're just going to go ahead and copy this. I'm actually going to be working on a system here later which will do this copy and paste junk for me. First, we're going to find usage of this to make sure I don't have anything using this. Okay, tile. This explains why we have a direct copy of the chest. Is we have a direct copy of the chest in one of the mods, which is right here. This is a 1-for-1 clone of the chest, most likely. And the reason I'm actually 1-for-1 cloning the chest is I plan to silently replace the chest in Minecraft, make sure everything is working here later, and then I'm going to be adding things like locks and filters and stuff to the chest. That way you get vanilla behavior out of a chest without actually having the vanilla chest. At least that's the plan. I may not actually fully do it that way. I've been looking at other options of handling that. But back to what we're doing. We're going to kill this class off, so no matter what we do, we're going to do it that way. So let's go ahead and do it this way, and then I'll rewrite that chest in a second. So delete all this, place all this in here. And then I want to come back over here, and I want to copy something real quick from the top. So we have a thing called iInventoryProvider, and it also implements iCited. So we're going to grab these two, we're going to place these here. What the iInventoryProvider is this is my external inventory system. Is that, I was reading that tweet there for a second, lost track of my thought. Okay, so this is my external inventory system. I use this for machines that do not require mod support for inventories, because the only thing I have to implement is get inventory, and that gives me access to inventory. I wish vanilla Minecraft used this system for its own usage, because it's so much easier to work with. Where vanilla's implementation is you got this class to tell you can access from outside, and then this is your entire inventory thing. And you've got to implement those on your entire system. Although in newer versions of Minecraft, they actually have segmented away the inventory a little bit. You still have to implement certain things, but it becomes a lot more optional of how you want to implement it. But we need to put this up here. So I extends iInventory. This is a generic is what this is called. This allows me to change what this is, and if you go to here, it's the same way. It changes this right here. So that way when you call get inventory on here, it will give you back the instance of this, and say instead of having iInventory, I wanted to put iExternal inventory, which is what I'm actually going to do. It'll then give me that handling there. There's one more method I need to copy out of here. It is actually this part right here, and I need to copy this. So I'm going to copy that part. And And then we're going to copy this part. And then I'm going to document this. Simplified implementation for I-sided inventory. Actually, we need to do it's a different way. At link I-sided inventory. When you do at link, what this lets you do. If I click here, I can then go to the class file. That's all that really does. It helps with your documentation. Now, if I converted this to actual Java documentation separately from the code, then you can go onto a website and you would see a full explanation of how this class functions, and then you can navigate through all the detail, but it won't give you code, which is something we plan to do here later because some parts of Volts Engine we want to be public, some parts we do not. Then we want to remove that part because that was only for the modular machines. And any other documentation I need to grab? No, that looks good. This looks all good. When we call get inventory, it's going to call this method here on the first run. This will create our inventory, and if I actually hit build, that chest class is going to error out, which is what we'll do is we'll pass in a create inventory for it real quick of 36 slots. I don't actually get why a chest has 36 slots when it actually only has a 20 size inventory, but I'm not going to argue with it, and I'm just going to implement exactly what it asked for. And now for our campfire, we're going to have to do this as well. Our campfire is going to be a 3 slot, so we're going to return new external inventory, and we want to pass like this, and I believe 3 is what it requires. When we pass in this, we're going to pass in the campfire, and it's going to keep track of our campfire. And then what it's going to do is there's a couple events it will fire for us, which is the reason I like using my external inventory providers. So let's see if I can find those. Yeah, on inventory changed. So anytime a slot changes, it will call host on inventory change. And we can feed on that event stuff, so we can tell when somebody adds fuel to our tile, when people take fuel out of it, when they take food in and out of it. This is something vanilla sort of has, but it only has it on the container class. And when you're making logic, you don't always want to be writing all your logic in the container class. I'll show you what a container class is in a second for those that don't know what it is. But first, we need to fix that chest class because it's going to error out when we go to launch. And there it is. And hopefully, this is coded so that it doesn't use that fill directly, so we can just go new external inventory, this, and then 36 slots. And then I'll look into seeing why it has 36 slots here later, but I'm not going to be working on this anytime soon. When I go to work on it next, I'll show you guys me developing it, and I'll try to explain why it has 36 slots. And most likely I can bring it back down to 27, plus the additional slots I need, because I'm going to be adding filters to it, I'm going to be adding locks, and those will be things you can edit, so you can put better locks on it so people can't break into your chest. I'm going to probably work on reinforced chests too, because I want to do a lock and break system here later. So you'll be able to hit a chest with a hammer, break the lock off, but then each item will have a random chance at breaking. There'll of course be fix for that. But focusing on the campfire, so we need to work on this. We're checking here. We've got our inventory. For our inventory, this is really simple. For item stack, it'll be tile dot. We're gonna use one of my advanced functions here. I was thinking like I can probably show you guys the normal way of doing this, but I'm like I don't really want to spend a huge amount of time working on this. So new inventory iterator. So I created a special class here using some of the fact that I actually know how to code in Java properly, where most mod developers don't. You can create an iterator wrapper. This wraps around your inventory, and then it'll allow you to iterate through your inventory as if you were going through a for loop. The normal way to do it is you would make a for loop that you would go from slot 0 to your last slot, and then for each slot you would check if it's null, and then you would output. With an iterator, it still does the same exact thing, but now it's only going to give me back slots that have content in it, which saves me a little bit of time on my designing of my for loops. So this will be tile dot get inventory. And then, yeah, we want to do true for non-null slots. The iterator is also designed to give you null slots back to you in case you want to iterate null slots instead. I do actually use both. But how this works, you'll go while it has next, and then you'll go item stack equals it dot next, and then we need to call inventory utility dot drop item stack, and we want this method world.x plus 0.5, y plus 0.5, and then z plus 0.5. As I noted in other videos, the block coordinate system here is actually the lower corner of the block and not the actual center. So when you go to do world coordinates, you want to drop something at the center of the block, you need to translate by half a block or half a meter. And this has a few other requirements. I need to provide the item stack, the delay, and the random float. So of course, this will be the item stack. Delay will be 0, and then false for, or actually, was that random float is what it wanted, so I think we're going to put 0 in here as well. The delay is how long it takes an item to pick up. You can set this on any entity item that drops into the world. You can say it takes hours to pick it up. This prevents people from just grabbing items quickly. A few mods have used this. A few mods use it wrong, like Galactic Craft drops with a second delay on its items, resulting in the item just kind of sitting there and you can't pick it up. I do 0 because I want the item to be picked up almost instantaneously. That way it's not sitting in the world. And then I don't do random float. The random float is the dispersion pattern. Minecraft has a default of, I believe, like 20 or 30%, so the item will fly away from you. I don't like the idea of the items flying away from you. If I can prefer it, I try to put the items directly into the player inventory. That way when you break things, you don't have stuff falling to the ground and stuff like that. We can do that with this, but I'm not going to because it does take a little bit more effort. Right now, we just want to drop the item, and then we want to go it.remove. It.remove will actually call, let me go to, I actually need to do this real quick. That way when I hit Control B on there, we go to this. This literally just calls set inventory slot null, which is exactly what we would normally do if we're clearing the inventory. In this case, we just call get it, drop it, and to be honest, we can actually call stack right here, and we don't need to store it, and that saves us a little bit of on the line time. You do want to make sure when you're using an iterator, if you're going to call remove, you access your item before you call remove, or else if you call remove, the item's gone, and you no longer have access to it. But we're going to drop the item into the world, and then we're going to remove it. That way, our break code is there by default, and we now need to actually do this real quick. Tile entity new, I don't want chest, I want campfire. Cool thing to know about these, you can actually return any entity you want, as long as you always return the same entity for the metadata. You can have almost a near infinite amount of tile entities per block, but you have to then get a little bit more intelligent how you implement it. By default, your limit's pretty much 16 tile entities per world. You can start changing your tile entities in different worlds, but this method right here only supports so many. You can get a little bit more specific by making a wrapper tile that then takes in as the object the metadata you go with the place. So you have 32,000 metadata values for your item. You can, in theory, have 32,000 different tile entity placements. But then what you need to do is place your first tile entity, encode into that tile entity what you want it to turn into, and then tell that tile entity to turn into something else. I don't recommend ever doing that because it doesn't work out very well. Anyways, this will be material.rock. And we'll go put that there, and then we need to set the hardness. So set hardness to, I'll say 1. We don't really care if this breaks. Set resistance to 1. That means after all it's a campfire. We then need to set block name. This will be, which by the way, since the last one, I did rename the mod. So it's called Survival Mod now. After all, that's what the client just kind of wants. We'll call this campfire. That's our localization name. And then we're going to need to set a texture here later. We're actually going to do this. Get icon. We're going to pop down to this method real quick, copy it. That's side and then metadata. So this is the side variable. And then this will be our metadata variable. And then we want to return blocks.cobblestone.get, and we want to do 0, 0 because we just want the icon to be the same. We're going to be using an ISBR for this, and the only reason we want to do get icon here is when you go to break the block, it will use get icon to get your block breaking texture. If you don't provide an icon, then your block will look like a pink fuzz when you go to break it. There are other ways to override the breaking texture by itself, but it's a good idea just to provide a texture no matter what. If you're doing a 3D model, provide a texture. You can just set it to cobblestone, gravel, whatever. My average is I always set the gravel because gravel just looks like anything when you go to break it. So it's got little particles that come off, slightly gray and pink, and it works for machines pretty well. That's all good right there. So we've got our basic functionality. We do need to do on block activated. This will open our GUI later. I'm going to go ahead and grab the method. And we'll go ahead and override this. And this is world XYZ. And then it'll be the player that clicks it, the side they click, and it should be the hit location. If you actually look at the documentation, it's also what it will say. That's the reason I actually know what all this is. But this is, that'll be the X hit location, the Y hit location. So it actually passes these in exactly. And the cool thing about having these is you can make keypads in Minecraft and stuff where you have to click the exact keys. Although you have to do a little bit of ray tracing if you make your keypad non-full block in size. But if your keypad's full block in size, then you can right-click the numbers. People have made some really intelligent displays with this. And then what's the final method? The final method I need to grab before we continue on to our quest of making this is I need to change the block size. So let's go to wherever this mod is. So I'm going to go copy a method out of another class I was already working on. Here we go. So we're down here, and I did the explosive last time and I got it working. You know, I put logs in the wrong spot. Let's move those real quick. I made the logs too. The logs were legitimately easy if I open this class up since I didn't show you guys making it. Here's our item. Here's the item. We set the texture, set the creative tab. We get the icon. We're actually pulling, we're pulling the icons from an enum. We register them to the enum down here. We're pulling the localizations from Minecraft itself, so we don't have to localize into any language for the log. So they're pre-localized to everything. Then anytime we break any object, does not matter what it is, if it goes to drop an actual block log, it will be replaced with one of our logs. This is per client's request as he wants to do whatever he wants to do. I don't really question, but this is the event. Here's our sub items. This tells us what shows up in the creative tab. That's the only thing it's used for. You don't need to use this if you don't care about creative tabs. This is our burn time. This is actually being done through an interface called iFuelHandler. This actually tells everything in the game how long our logs burn, and it matches the actual Minecraft log value. I might change this over to something slightly different. That way, if another mod changes the log burn time, this updates with it. And then here's our enum right down here. So this has all of the Minecraft log types in it. And if the client really wants to, I can start adding support for other log types, although they'll have to be individually added. And okay, there we go. So we'll go back to working on the campfire. So I wanted to go quickly grab down here. I got special collision boxes for the C4 explosive. I want to go ahead and copy this, that way I don't have to spend a huge amount of time coding this part. We won't need all of it, we just need this line right here. And we'll go ahead and kill this off, and we'll replace it with this. And then we just need to change our size. So I want to come away 1 pixel. So pixel size. I actually had to start doing this in pixels because my text artist is like, hey, can you please keep all of your changes to pixel sizes? That way it actually works out well. And then we want to do... Actually, for the collision box, making it to pixel size doesn't actually matter, so I'll probably come back through here and redo this. Considering our campfire is not a perfect rectangle, I don't think, but we'll do pixel size times 6. And that'll be close enough. Let me go fetch our models, since I almost forgot about that. So I want to go Google Drive, Work, Built Broken, Minecraft, Requests. Then we want to go to the model folder first, and I think there's a texture folder too. So here's our fire pit. And he's went ahead, and I don't think I need to grab these. But I need to open this up and take a look at this. I think what he told me is I'm going to use Vanilla's texture system to actually render this. But this is our fire pit right there. So these would be cobblestone, our base would be dirt, and this would be these would be logs. Hopefully, these are separate faces because I can't render the log top here on this without a proper UV. I may actually have to end up asking him to UV the logs individually, that way they don't just look like this material wrapped across the whole thing. But that should do the trick here, so I need to just go ahead and copy this. Oh, should I close the folder? Will it show up my closed list? Yes, it does. There it is, recent. So we want to grab this, we want to open this folder up. This is apparently ICBIM. I was working on, I fixed a couple bugs in ICBIM here a few minutes ago. Nothing major, just a couple, some minor bugs. We'll go back to here, and then right here sysmod. Source main, resources, assets, Wojujo, and then models. Why is there actually not, have we not, I guess we haven't put any models in this one yet. So here's our fire pit. And then we want the fire pit material file. This is our material. And then DAD, that's also a model format for those who are familiar with the collada model. We actually want to transition completely to collada models eventually, but right now we're using object because that's what Minecraft can load. Minecraft only has support for 2 model types, and that's Techni and objects by default. Technically, those are both implemented by Forge and not Minecraft. Minecraft uses its own class structure system, but its class structure system is the same as Techni, though Techni technically is implementing its model system, but it just has its own custom loader for it. But there we go. That's our model. So we're gonna hit that up with an IS. Well, actually, I don't know. Can I implement that? Let's open this again. Oh, cancel. I don't want that. Its geometry won't allow for it. I was like, I could render this with an ISBR, but then I'm like, it's got triangle geometry. If it used square geometry, then I could definitely render it with an ISBR, but it ain't gonna work. So we'll need a tile entity render for this one. I guess it lets me show you guys a little bit different here. So we'll go ahead and do this. It'll be tile entity campfire render. Actually, let's rename this again here to stick with convention a little bit. We'll put render in front of campfire. And this will be, I believe it's just tile entity. I think it's tile entity render? Tile entity special render, I think is actually what it is. Tile entity special render. Yeah, here we go. That's exactly what I'm looking for. This is the base level render for tile entities. It's literally this simple. There's nothing to it. It's got a bind method. It's got ways to get your text and stuff. And it passes in a tile. It then passes in the translation from the player to where you're at. So this is not the actual location of the tile, although you can just call the tile to get its location if you ever wanted to use it. And I believe this last one is frame delta is what this is. So it's the amount of time in nanoseconds it took to go from your first render frame to your second. Tile entities, when you use this class, render every single frame. ISBRs render once per update. Although technically render calls being called every tick still on them, they only cache once. You can cache these as well, but it's not recommended. And in this one, we want to go really quickly to our ISBR. Oh wait, not the ISBR. I want to go to the grab on hook mod. Okay, I just want to copy these two up here. I always hate typing those in. So we go over here, put this in here. We'll get to the render part of this later, but if I get all this stuff pre-implemented and we load up Minecraft, we won't have to restart Minecraft. This needs to be our domain name, so we're going to call survivalmod.domain, and we'll do that for both. If you don't put your domain name in here, you're not going to load a texter. We got models, and then this will be, we don't have a texter, so actually I can get rid of that. And this will be models.campfire, I believe. Okay, it's actually fire pit. Shoot, I typed in some code there by mistake. So fire pit. And then the material file in 1.7 is not loaded, and newer versions of Minecraft it is loaded, and this actually does affect how textures render and everything. Right now we don't have to worry about it, and by default it's set up to be really basic materials. In this case it would just tell me that what Morton actually used for everything, and to be honest I can't even use it because he's actually set this to use his Google Drive folder, so I'd actually have to come in here and fix all this. Although I think this would actually correct itself, but he used 4 materials. He used a coal block, stone, log, and log top. Unfortunately, I don't think the model system will load his material. But I think I can do this really. Actually, I won't write the method code for that real quick right now. But we'll go to here. So we got our update code. So we need to keep track of our fuel timer, and this will be set to 0. And then we need to keep track of our cook timer, which will also be 0. And then we need public static final int slot input, which will be 0. Public static final int slot output, which will be 1. And then public static final int slot fuel equals 2. What these will be used for is our inputs and outputs, which we'll also cache here. The reason we're making these final and static is it caches them so they aren't recreated every time we create a tile entity. And making them final, we don't have to worry about people changing our data on us. Because if you make it static, somebody can change it. Usually you don't have to worry about that, and even when you put final on that, you're still not safe from this. There are ways to get around final, but that you don't have to worry about that. So we need to do input slots, and this would literally be new int array, and then this would be slot input, and then slot fuel. And then we'll do the same thing here, because we're making this accessible by side just because it's a good habit. In reality, because this is a campfire, you wouldn't actually be worrying about this, but it's a good idea just to do the practice and get it running. And then there's a method for this. It's get accessible sides or slots from side. This goes to our wrapper class by default, but we're going to override it in the tile, so that way we don't have to override our wrapper class, which is the external inventory here. So if our side is if side equals 0, which is bottom, we want to return output slots. I believe the furnace is programmed slightly different, where you can't input fuel from the top, and it has to be inputted from the side, I believe. I'm just going to go ahead and make it where you can input fuel from all sides, because it really doesn't matter. Gameplay-wise, it doesn't really change anything. And if we really wanted to, we can say, okay, you can't input from like the top at all anyways. But because none of the models are ever going to mesh up properly with any other type of piping, it doesn't really matter how we make it look. It's up to the player if they want to do that. And then we want to do can insert item. Yeah, so we want, actually there is a method set we have to override because we're using this. And can I get rid of this? There we go. Yeah, we want these two methods. So we'll put these down here with the rest of our inventory code, and we'll go ahead and implement them. These are used by my providers only. My providers do wrap to them by default. So we'll go ahead and do this real quick. And what these do is they're pretty self-explanatory. An external object would ask, can I store the item? And you would say true or false. We're going to put this by default. And then we have to, actually when it goes to remove, if slot equals output slot, we'll just say true. Why is that not working? Oh, I did output slots instead of slot. I misspelled output. Oh, slot output. My bad. Here we go. And then on this one, we want to go if slot equals slot input. We then want to have handling for that, and we want to go else if slot equals slot fuel. We just literally want to return is it fuel. So we'll go return. I believe it's tile entity furnace is where you check fuel at. It's fuel item, and then you just go like that. There we go. That works. We don't have to do anything with that. Pretty self-explanatory and easy. On this one, we're going to have a recipe system that we'll have to come back and implement here later. So we're going to just return false for automation at the right moment, though we'll put a to-do thing saying implement when recipes are added. So we'll have to implement our own recipe system. And if we actually go to the furnace real quick, we actually could probably use its recipe system. I believe it calls... That's what I was talking about, by the way, when I didn't want to implement the inventory code in the camping fire, is most of the furnace class is inventory code. After that, you get things like cooking progress scale, which are used only for the GUIs. This is our main bulk right here, which is pretty self-explanatory. We decrease fuel. If it's the server, we then go, okay, what are we doing? So we got our furnace burn time does not equal 0, or we have items. We then can up our fuel time and stuff like that. Yeah, so here's where this whole entire part right here is dedicated just to consuming fuel. Here's what increases our cook time, and this is what's called when we're going to smelt the item. Anytime our burn time changes, we update the block, because the furnace actually has 2 block tiles for it. I don't know why they did it that way. It doesn't exactly help the game any. Here's what we call get smelt. Yeah, so it's got a furnace recipe handler. So if we go to the furnace smelt recipe handler, this is literally what we're going to implement for the cook fire, and I can just straight out copy this. I'm not going to, for the simple reason that it's not hard to implement, and I'm going to implement the recipes directly into the campfire because I don't need to care. So we'll go up to here. So this is it's our renderer. We don't want that. We don't want our block right now. We do want our campfire. So when we go to implement recipes, how they would be implemented is we would have a public static. How do we want to store this? We want some way of going input to output. So let's go. We'll use a hash map, and we'll use my item stack wrapper. You can't use item stacks in a hash map because item stacks themselves do not have a way to implement and work with hash maps. They don't have an equals method, and they don't have a hashing method, meaning that each item stack created is a unique object. But when you use the item stack wrapper, what this does is it comes down here at the bottom, it goes, okay, are you equal? And then it will check to see if 2 items are equal with each other. Although I've kind of broken the rules on this one, I've actually checked against item stacks. When you make equals methods, they need to be equal in both directions, which means item stack would call equal on mine, and I would call equal on item stack, and in those cases, it would not work. I would actually get a violation. But luckily, I only actually ever use the equal method when hash maps for this right here. Any other attempt to use it, so if you say you had item stacks and item stack wrappers in the same hash map, you would actually crash the game. And then you got the hash code down here, which makes a hash code that out of the items, because it keeps track of the stack itself, and then goes, okay, do we want to compare metadata, do we want to compare MBT, do we want to compare stack size? By default, when it is created, it will only keep track of metadata if the object has subtypes, and it will only keep track of MBT if we have MBT. It does not care at all about stack size. You have to force it to care about stack size. So in this case, we're just going to go ahead and use that because that works out rather well, and I accidentally fat fingered a key. So we're going to go up here, and then this will be, then we'll just do item stack for the result. This will be recipes. That is legitimately how easy to make recipes is. And we can also do up here at the top, public static void add recipe item stack input item stack output, and then it'll be recipes or recipes dot put new item stack wrapper input, and then we would do output. That's literally how simple it is. And then we would actually probably, we'll throw that to the bottom of the class because we don't want it at the top. How you handle static versus normal methods is entirely up to you. There actually, as far as I've been able to tell, is no documentation on it. I just interweave my static with my normal methods usually. I've seen some people that'll put all of their static stuff at the bottom, including this stuff. Although I really hate it when that happens because you're going through the class and you go, oh wait, there's like 50 fills down here, and you go like, why the hell is that way? You even can hit up, Thermal Expansion has this problem where I believe Skyboy codes all of his fills at the bottom of the class. It improves readability in some extent, but then as somebody like me who's going through a class file to try to figure out what Thermal Expansion is doing so I can interact with his tiles to add support, it makes it harder to do work. But it doesn't really matter too much. The only time I'll ever peg on a developer about how he's handled something is when it gets almost nearly impossible to read his code, or his code is intentionally breaking the game. I've only actually had to yell at a few developers about that. Most developers actually do write half-decent code. That at least it works. There's been a few developers like you have Reika who doesn't know how to write performant code, which I don't blame him. He's an engineer, he's not a programmer. Can I actually do this? It's sweet, it actually does recognize this. Cool. That saves me a little bit of time. So I added a block and item here. This is just to keep in the standardization with how Forge does it. Forge also does a block input and then an item stack handler. So that's the same in case somebody else wants to add recipes to this. I'm not going to do any override warnings. Usually when I do recipe handlers, I'll do an override warning saying like, hey, somebody's overriding this recipe. That way in the log, you clearly see that behavior. I'm not going to put it in here because I should be the only one adding recipes. But we'll go ahead and I want to say we can actually just implement the code without even launching the game here. So we'll go, we want to check our burn time. So if fuel timer is less or equal to 0, we want to then up our fuel timer. We want to do this all server side. So if world object is remote, this tells us that we're a client. If you put a thing in front of it, it'll go, okay, we're server. Because if you're not a client and you do the not symbol, then you are a server. So you're like not client, which means the same as server. So we do all of our actions server side. If you looked at the furnace or we're paying attention to it, it actually does a lot of stuff client side. I sometimes will do that depending on how I want to handle things. In this case, we're going to do everything server side, and then we're going to packet sync our data to the client. So we'll packet sync our burn time to the client, we'll packet sync our cook time to the client. So when you have the GUI open, you'll see all that, which means we actually do need to implement iPacket ID receiver. I'll go ahead and implement those methods. And if I actually go in here real quick, I want to extend, I have the tile entity base here. Oh, that doesn't get squat in it. There's one of these that has code in it. It's not tile. I actually think it is tile. That's the reason why we don't have it. But I have a version of my code that has a pre-implemented packet handling system in it, and I'm just going to have to replicate it on this and just have to bite the bullet on that one. We're going to move this above our inventory code though, so we can find it easier. And we're actually going to do this real quick to make the code just easier to read. So we know everything below here is our inventory code. This is something they never teach you in class or any kind of programming classes to do this. It was taught to people that have been doing the industry longer. That's how I found out about it, is I was told by somebody who has clearly been programming much longer than me, is that when you make code, it's a really good idea to put these big breaks in here. That way you can see things. I've actually programmed with a few IDEs where this will allow you to down scroll. Like if I do this, I can get rid of it. Instead of doing that, it would have down screened this entire part down here for me, which makes navigating your code incredibly quick. We'll do packet code, and then we'll do this as well. So this is save code, and this will be our packet code. I do this on some of my classes. You won't see me do it on all of them. It depends on just how enthusiastic I am during the day when I go to do this type of behavior, and how big the class file is starting to get. And then of course I need another one down here real quick. This will be your recipes. There we go. And that segments out our class file, and then we can also document a few things. It's a good idea to document your code, so we go like, hey, this is our recipe object. Actually, let's make this private, so you can't access it from outside. Map of inputs to outputs. This will be remaining ticks on fuel. And this will be progress on cooking items. And then I don't really care to document. These are self-documenting. And then we also put up here simple campfire entity. If I can spell camp. Okay, there we go. So when we get to fuel timer, and we'll go ahead and go like, hey, we don't have fuel. We then need to increase our fuel. And what we can also do here, if we put this minus here, this will automatically decrease our fuel. Or actually, let's not do it that way, because that will end up with a really large negative number, and if you leave it going too long, it will actually crash the game. It'll take it legitly forever to crash the game, but it will eventually crash it. Somebody was reporting a bug to me about somebody else's server, about a mod I did not make, where they're like, hey, I keep getting this crash report on my server, and they're like, how long you leave your server on? It's like, we left it on for 30 days. I look at the crash report and I see like, index, or no, it's not index, it was something overflow or underflow. I don't remember what it was, but it crashed the server because then this number went down to negative like 2 to the power of 32. And there was some kind of logic in the code that required this number to always be positive or the game would fail. And it went negative simply because this number went below 0, by such a huge amount that it crashed the game. By the way, if this actually does go all the way down to negative 2 to some 32, it'll actually turn into 0, and then it'll start counting up rather than down. That's a nice little bug with Java and a few other languages. It's intentional. It's called underflow is what it's called. And then you can get overflow, which is the opposite direction, where you count too high that the number reverts back down to the lowest number below it. And the reasoning for this is you've got a limited amount of space you can store a number in. Java integers are 2 to the 32, if I recall right. And then doubles are 2 to the 64. Floats are, I believe, 2 to the 32 as well. Or something like that. And that size changes depending on what operating system you're on too. 16-bit, it's a lot smaller number. 32-bit, it's a smaller number. But we got a fuel timer here, so we're going to go, okay, for below, if, actually do this way, item stack equals get stack and slot, and then we'll go slot fuel. If stack doesn't equal null, and tile entity furnace is fuel item stack. And how does it actually check fuel item? Oh, it goes get item burn time. So we're actually going to copy this method is what we're not going to copy. We're going to go back to here and remove this, and we go int burn time equals tile entity furnace dot get item burn time stack. If we know that burn time is greater than 0, it's a burnable item. So then we want to go fuel timer plus equals burn time. Then we want to keep some kind of tracker here. So public boolean do update client equals false, and then we want to go do update client equals true, because we want to send a packet every time we consume fuel. Not because we actually consume the fuel, but because this fuel time may now be above 0, which means we now want the fire to start burning. And then at the bottom down here, somewhere at the very last second, we'll go if do update client, and then we'll go, okay, do update client equals false, and then we'll go to do send description packet. We don't need to update every time we do this. We do need to keep track of who is accessing our tiles, so that way when you have a GUI open, we're sending a packet every 3 ticks. You don't want to send one every tick because it's unnecessary, because the response time of a player is going to be 3 ticks pretty much. For record, what 3 ticks is, so every second you have 1,000 milliseconds. The server runs at 50 milliseconds a tick, so you've got 20. So 3 ticks is 150 milliseconds. The average human response time is between 200 and 300. So your brain is only going to register input and react to input between 200 and 300 milliseconds. Anything quicker than that, then somebody's clearly spamming the left click button to try to get a reaction out of something, which means they're not aware of what they're doing, they're just spamming, or it's a robot. Either way, you don't care, because the client doesn't need to be updated quickly anyways. You're just trying to make sure it doesn't look like crap when it updates. That's the entire goal of making sure your packets update. And when you only send it every 3, you're actually helping the server out just slightly, because you're not sending as much packet data. And what you can also do is randomize that 3 as well, so your start time on your 3 is not always the same as every other tile. Because when you load a world, all tiles are going to have the same start time, but if you placed one after another, they're going to have a slightly differentiated start time. And if you can have a slightly different start time for a tile, that means you're not sending packets continuously. If you send a whole bunch of packets every 3 ticks, you're going to have a large stack of packets being sent at one time. But if, say, you had 3 tiles and each one was starting at a different time, then you're only sending a packet for that one tile per tick, and then the next tile sends its packet, the next packet gets sent out. It actually helps consistency with server bandwidth, and you don't have spikes. This is something I actually helped rake out with for who does Warriorcraft. His packet handling was so bad that you could get hit with a spike that was over several megabytes. Now my internet right now, I think I do 10 to 20 megabytes per second. I used to have an internet that was under a megabyte. I could not log into his servers with his mod packs because of it. My internet was incapable of keeping up with his packet handling. Now I could do that. But we got burn time. So we're iterating here, and now what we need to do is we need to decrease stack size. So we'll go slot fuel, and we'll go 1. What decrease stack size will do for us is it drops the stack size by 1, and if the stack size is below or equal to 0, it'll delete the stack for us. If we actually open this up, of course it does wrapper to my method here, but it works. I'll just assume that. If you want to go see the code, you guys can go open that up. I don't need to explain the entire inventory system. But this will keep our burn time going up. And if we're going like here, so if we got else, so we know we're burning, we're going to go down a time, so then we're going to go if figure out how we're doing this real quick. We'll do another Boolean. I hate doing Booleans for this because this can backfire on you. Has recipe. The trick though is if you do this and this does not backfire on you, it is more performant. There are mods like I don't want to say Tinker's Construct. Thaumcraft. Thaumcraft has an issue with one of its machines where it iterates its recipe list every single time, every tick, to go check to see if it can do the recipe. And because it iterates its whole entire recipe list, if you get too many of its machines, which happen to be, I believe, the automated crafting table, I want to believe. I don't remember what machine it was. I fixed the bug for somebody a while back. But it will tick so often checking the recipes, and you'll get too many of them, it will actually slow a server down. And this is where you don't want to check your recipes often. If you can help it, it does improve performance, because a Boolean is only 8 bytes. Actually, no, it's 1 byte in memory, which means that's really good. You could have like thousands of these before you start affecting the memory usage. But if you're checking recipes every single tick, you're affecting the CPU usage pretty hard. And if you can save CPU by only sacrificing a byte or 2 at a time, you need to go with that option. So we have a recipe. So if we go, if we don't have a recipe, we need to check to see if we have a recipe for starters. And how we check we have this, we go if, or go as has recipe and get stack and slot. So we'll get stack and slot, and there'll be slot input does not equal null. Oh shit, I want this to be over 1. So if we don't have a recipe and our input slot is not empty, we then go, hey, we got an input slot. So we go item stack, stat equals get stack and slot. You don't have to worry about, like, I'm actually calling get stack twice. This operation is really fast. especially if you're using one of my prefabs. My prefabs use hash maps, and hash maps are incredibly quick. So you never have to worry about speed here. But we're going to go if, actually we want to do this an item stack wrapper. Because what we're going to do is we're going to check this list up here. I'm going to go if recipes dot contains stack. If recipes contain stack, then we go has recipe equals true. And all we have to do is there's actually a method I can do to keep this in check. So on inventory changed. So we want this method. You know, I was talking about how this, every time the inventory changes, this is called. So we want to keep track down in our inventory code. If our inventory changes, we want to then say we no longer have a recipe. So public void if slot equals slot input, then we want to go recipe has recipe equals false. And we want to do this only on the server, so if world object.is remote. And we'll make sure we put the exclamation on there. And we also want to do update client equals true. And the cool thing about doing this also is if this code runs and it goes has recipe equals false, this will run before our packet is sent. So if we verify that there is a recipe now, we can continue burning the recipe. Unlike what Ender.io does, and then you change stuff and it validates your recipe completely. Or actually, it actually eats the items, so you can't even change the recipe mid-run. Which, realistic-wise, actually helps with the realism of the game, but when it comes to how other stuff works in Minecraft, it kind of throws you off slightly. It's all about design choices, though, and in that case, it doesn't really matter. And of course, we want to do update client equals true. So we want to make sure we're updating the client every time we change something. So we have our recipe. So now we know we have a recipe, and then we want to just go right below this, if has recipe. Now you don't want to do an else statement here because you want to make sure that that first tick you have a recipe, you've ticked your cook time up. But what you want to do is if you don't have a recipe, so else you don't have an upright date, you want to go cook timer equals 0. So if at any given time there has been one tick, only a single tick where there's no longer anything in the furnace, you then want to turn off your cook time so it resets for the next item. In this case, we're going to go cook timer plus plus, and we want to go if, what is the furnace? So let's go check how long the furnace takes to cook. We want to match it 1 for 1 unless the client tells me otherwise. It's 200 ticks. Cool. So I'm going to go if cook time is greater than or equal to 200, and you want to make sure you do the greater than or equal just in case for some bizarre reason your cook time gets set to 200 to 1, but you're always checking for 200. Your furnace doesn't freeze up and lock up on the player. Greater than equal check compared to an equal check run in almost exactly the same amount of time on the CPU because Java is intelligent and has programmed its native implementation really well. So you don't have to worry about this taking any more time than an equal and equals check. Cook time, let me document this stuff too real quick before we move on. So we actually want to do this too right quick. If fuel timer is greater than 0, so we want to check to make sure fuel. So we go if we have fuel run system, if we have no fuel get fuel, if we have no recipe, find recipe. If we have a recipe, tick recipe timer. Okay, so that's documentation, so when somebody comes back through here, they know what they're going on. And of course, I need to go down here, send description packet. Some of this code is actually self-documenting, and what I mean by self-documenting, if you read do update client, you understand what do update client means. It's not too hard to understand that this has something to do with taking data from the server and giving it to the client. But some of this other stuff, you don't know what's going on. So like, what are we doing here? We're checking fuel time is greater than 0. But what's that do for us? I mean, you can infer what's going on, but if you have a documentation up here, so it goes, oh, if we have fuel, we're going to run the system. So this must be the system's main code loop. And you want to keep documents like that because it helps other people understand your code. It helps people on your team understand your code because I work with other people occasionally. And then if, say, I go off for several months, or even if I come back, like, say, intoxicated or half asleep, I can read my own code. Not to say I ever actually do that, but I have been pretty exhausted before trying to code, and that's when days I've went without sleep, which I recommend don't go without sleep. If you're going to code, don't do what people tell you and to try to go all night. Get sleep, do it in the morning. You'll code quicker if you actually have had sleep. But cook time. So we want to grab our input item. So we want to go get stack as input. Actually, I didn't want to cut that. I want to do this real quick. So item stack input equals this. Actually, we're going to need an item stack wrapper. So we'll go if input doesn't equal null. Because you want to check to make sure your input doesn't equal null. Because if ever that has recipe backfire on you, you do never want to assume your code is valid at any given time. Because you're dealing with user input and stuff, and say for some stupid reason your item stack disappeared and did not call this on inventory change method, you would be assuming that you have a stack. In reality, you don't, and then of course it's going to try to run and it's going to fail. So you want to make sure you validate it at some given point during your process, because you also don't want to duplicate items as well. But we're going to go, okay, if this doesn't equal null, and then we're going to go, okay, if, okay, we'll do this, output equals recipes dot get output. If output doesn't equal null, and then you also want to do and inventory utility dot stacks match. The reason I'm doing stacks match is I want to make sure that if I go to put the item in the output slot, that I can stick in the output slot. And actually, well, there's two conditions for this. So they want to be if, I need to actually this, output. So we're going to call this recipe, and we're going to call this output. So I want to make sure I switch these around. So we want to check the recipe, and we want to check the output slot. I can't spell today. Yeah, I can't spell. Luckily, IntelliJ's got my back here. I think it's right. Okay, we definitely are going to check Google now. Ignore that document you saw. Not that it matters, this stuff's public record anyways. That's how you spell it, damn. Okay, so get inventory, or yeah, get slot, or get stack and inventory. My brain is slowing down right now, so this means I need to hurry up and quickly finish this so I can end this video, because we're at an hour. Which means I need to go take a break here, eventually. But we got output, so we want to make sure that our recipe matches our output. But at the same time, if our output equals null, which means we have nothing in that slot, then we want to make sure it works as well. And then on top of checking if it matches, we then want to go inventory utility dot, I believe it's space. It's actually called room left if I remember correctly. Yep, room left. So it would be this, and then slot output, and then we were to go greater than 0. So what this works on is we match to see if the recipe item is the same as our output. Then we check to see if we have room left. It goes, this method literally is really simple. It goes, okay, what is our maximum amount of space we can possibly have in that slot? Because different inventories have different max slot spaces. Where a chest may have a 64 stack size, another item may have, or another chest may have 20. And it's rare, you never see it in Minecraft, but there are chests that do have that. On top of this, there is a stack limit of the item itself. This is why there's a reason men here. Some items do not stack to max, and you want to respect that. You don't want to be putting 64 items in a slot when the fact is the item can only stack to 4. There are mods that do this, and they need to not do this because it breaks the immersion of the game. Unless they state some kind of other logical reason like, oh, we're intentionally doing this because the chest compresses items. But this will give me the max space, and then it will actually minus max space by stack size limit, and it will return the amount of room left. I also actually do use this to check to see if chests have overcapacitated, and I will clear chests out if they are overcapacitated. And by clearing out, I just throw items on the floor. So we know our recipe is at null. We know we have space left. Then what we want to do is decrease stack in our slot. So this will be slot input, and we want to decrease by 1. And then we want to have two conditions. If output doesn't equal null, and then if output does equal null. So we want to go, if output, we want to set inventory slot content, and this will be output slot, or it's actually slot output. And then we want to do recipe item. Recipe item.copy, actually. We want to make sure we're copying this. The reason we are copying is because recipe is returning the actual item stored in the recipe list. If you modify this, you modify the recipe. If you pass it back to something like set inventory, that means both the recipe and the inventory are sharing the same exact copy of this item stack. And if I edit in the inventory, it'll edit in the recipe list. I have actually screwed up doing this before. I've watched other people screw up doing it before. It is absolutely hilarious when you do it, but you don't want to do it. In this case, we want to go... actually, you know what we want to do? Instead of doing this, we want to do if recipe dot stack size. I almost made a mistake here. I was checking if greater than or equal to 0, which means that if we had any room, assuming that the recipe was always an output of 1. There are recipes that could potentially output 2 to 5 items or something like that. If you're always checking for a space of 1 and you try to merge the two stacks, you're going to cause somebody to lose items. In this case, you want to check to see if we have equal to enough or greater than enough room. So that way when I go like this, I go output dot stack size plus equals recipe dot stack size. Because if these two items match, all I have to do is increase the output stack size, and then all I have to do is then go and update the output slot. It's optional to update the output slot, but it is recommended to update the output slot. That way you trigger events like this down here, because this event doesn't get triggered unless somebody calls set inventory. So it's a good idea to do that, especially if you're working with other people's machines. You always want to trigger set events on their stuff. You never want to directly manipulate their inventory and then assume it'll work, because code will fail. But this is functional, and we want to, at the bottom here, cook timer equals 0, and then do update client to true. And that's our full functional code. We'll have to test it in a second to make sure it does work, but there's a lot more work to do with this. I'm going to do this on the next episode of this when I see you guys later. That's been it so far. We got most of our stuff done.